Example, find the extreme values of f of x equals x to the power of 2/3 times the quantity x squared minus 4 on the closed interval from -1 to 2. To find extreme values, we got to find critical values. And critical values occur where the derivative equals 0 or the derivative is not defined. Let's find the derivative. F prime of x. Let's observe that we have a product function, a first function times the second, and when in finding the derivative, the product rule says you take the derivative of the first, multiply it to the second, add it to the first function, times the derivative of the second. The derivative of x to the 2/3, bring the 2/3 down, x to the power of 2/3 minus 1 is minus 1/3. The second function, x squared minus 4, plus the first function, x to the 2/3, and we take the derivative of x squared minus 4. The derivative of x squared is 2x. The derivative of 4 is a 0. Let's write this with no negative exponents. This gives us 2 times x squared minus 4 in the numerator divided by 3 times x to the power of 1/3, plus, then we have 2x times x to the 2/3, and it's understood that its denominator is 1. In order to combine these terms, we need a common denominator. So we'll multiply the numerator and the denominator of the second term by the denominator of the first term. In so doing, we have a common denominator, 3x to the 1/3. Let's distribute the 2 on the first term, so we have 2x squared minus 8 plus, and we'll distribute the 3x to the 1/3 to the term on the second one, which just means multiply it out. 2 times 3 is 6 times x, and x to the 2/3 times x to the 1/3 is just x. Combining the stuff in the numerator, we will have the 2x squared plus 6x squared. That would be 8x squared minus 8 divided by 3x to the 1/3. For the derivative, f prime of x equals 8x squared minus 8 divided by 3x to the power of 1/3. We need to solve for where the derivative equals 0 and the derivative equals 0 where the numerator 8x squared minus 8 equals 0, and the derivative is undefined. If you let x go to 0, because that'll give you a 0 on the denominator, so you have x equals 0. Let's solve for the x values where the derivative equals 0. 8's common, factor that out. So you have 8 times x squared minus 1. Factor the difference of squares, so you'll have x minus 1, x plus 1, Then we have critical values at x equals -1, at x equals 0, and at x equals +1. Now remember the closed interval from -1 to 2. We'll need to evaluate the function at the endpoints and all critical values that are included in the endpoints. So we want to solve at x equals -1, at x equals 0, at x equals 1, and at x equals 2. And do this in your calculator, it'll just be quicker, for f of x. Not f prime of x, but for f of x. F of x at -1 in your calculator, the output is -3. Computing f of x at 0, the output is 0. Computing f of x at 1, the function value is -3 again, and the function evaluated at 2 is 0. It looks like we have repeating values, and so we see that we have the least function values at -1 and 1. We have absolute mins, that's plural, at x equals -1 and at x equals 1. And we have two high values, which are 0. And so we have absolute maxes at x equals 0 and also at x equals 2.